focusing on here in Synapse is, for very large data warehouse workloads, but also workloads that weren't traditionally the remit of your data warehouse, that Synapse has a very unique place where there's not really any other vendor that can do what Synapse can do as a suite of tools, and that's what it is. The MPP engine is just a small part of it. It's certainly going to allow you as an organization to leverage insights off your data a lot quicker than traditionally we could have. And that's really what the key message of Synapse is. So I love this slide because this sort of tells the whole story of Synapse. So Synapse being the core of our data and analytics ecosystem here. And what it provides is a bridge to connect then with Azure Data Share. We have Azure Purview as well, so our data cataloging tool. Power BI is integrated into the solution, and also our Azure Machine Learning. So Synapse being the place where you provision the data, you land the data, you engineer the data, prepare the data, and then it goes on to those consumption phases. But really, you do need some of the other tools around there. Now, not saying that it's exclusively locked into these, but you just get a seamless end-to-end experience when you merge it with those other tool sets. And I'm going to go back to basics. So what workloads are not suitable for Synapse? Well, we're talking about operational databases where we have a lot of individual row inserts and updates happening within that system. Also, row by row processing is not it. We're talking about bulk processing of data in Synapse. And that could be of structured data, but also it can be of your semi-structured data as well. So here we are with the workloads that are suitable. So large volumes, as I mentioned, a great data acquisition layer. So if you have data that's distributed across multiple systems, and that could be SQL Server, Oracle, any other relational engine, but it could be across different locations. But also we can acquire your semi-structured data as well and flatten that out so you can analyze it. We're talking large daily loads, or you can even go to batch, micro batch loads as well. And what we mean by that is, smaller amounts of data that would be processed less frequently. So maybe, or more frequently, 5 minutes, every 5 minutes or so, down to that sort of level, not our real-time analytics. It's also great, and this is my favorite bit of Synapse, at performing just ad hoc analysis across large data sets. And I will get into that. And it's all very familiar. So if you're familiar with SQL, Synapse is just an easy place to get involved in. So what we're seeing now is it's not just a data warehouse, it's also introducing our big data and our data lake into a single solution. So we get the best of both worlds. We can analyze our structured and our cleansed and our prepared data and merge that and mash that up with data sets that have not been cleansed or curated or transformed. So you can start to clean that data up very quickly and easily, mashing that up with your pre-prepared data, and just see what insights you can generate out of that, which is a really unique value proposition of this solution. Now, good old formatting has beaten me on this slide because these are the things I just wanted to cover off briefly. What we will do is go to the install. What I have I always have one already prepared, but what we're going to do is we're going to create a new Synapse. So I'm just going to click Create Resource here, and this is how we install Synapse. And I'm going to type Synapse in here. And here we are, Azure Synapse Analytics, and click Create. Now, there's a few other steps that you need to do. Create doesn't mean it's going to go off and do this. But what we're asked to do, as with all Azure resources, when we create them, we want to put it into a resource group. So I'm just going to create a new one. Test. Come on, there we go. And then a managed resource group name. So there's going to be some resources that are not automatically deployed in that resource group. It's just help sort of organizing things. These are all the things that will be managed by us in the background. So I'll just call it Synapse Managed Resource Group. Now your workspace name. So this is going to be the name of your Synapse workspace. And your Synapse workspace is the area where you will do the majority, if not, depending on your organization, if not all the interaction within your Synapse experience. So I would say select a good name. I'll call it Tanya's Workspace. Yay. Region, very important to get the right region. You don't want to deploy it in the wrong region and then have really bad connectivity, as in when you're pulling data over, it takes a long time because you're pulling data from Australia to the US or something like that. I'll just leave it at the US, and then we're asked to use a storage account. I'm just going to use an existing storage account. So if you already have a data lake,
Henry,
you can, yes, Tanya.
We just have a request for you to expand your window to your full screen and zoom in a little bit, pretty please.
That is no problem. How is that?
That looks much bigger from my perspective.
Everyone
Thank you very much.
that? That's good. So this is important to understand. So you can connect to an existing Azure Data Lake Gen 2 storage account if you wish, or you can create a new one if you wish for Synapse. Now, if you create a new one, it doesn't mean you can't connect to your pre-existing one. So it's just, I suppose you can have a shared workspace where a lot of people are working in with other tools on that storage account, or you could have a dedicated one for Synapse where you sort of go, okay, I'm going to keep it physically isolated. That is entirely up to you. Yes, SQL logins are still supported.
Not sharing your password with us, Henry? And you've gone on mute.
How did I go on mute? I use the same password for everything, so I'm not going to share that. But I've figured out there is one password I found that every Azure resource accepts. It passes all the rules. So that's the one I've been using for the past few years.
Yep. I'll to that when it comes to POCs.
Yes. So here's an important consideration for Synapse where you can bring your own keys to the service. So if you are super security conscious and you want to manage all your own keys and you don't want to use Azure Key Vault, we can certainly use your own, what are they called? Sorry, the word has escaped me, or the acronyms escape me for the moment. But your own certificate servers, as it were. Sorry, the word is gone. Somebody will help me. Mike generally jumps in at these points to put me on the straight and narrow. So this is something to remember about Synapse, because with a lot of other services, if you want extra bits, you're charged extra. with Synapse, everything comes with Synapse. That's it. You have everything beginning to end, all the security, all the features, all the capabilities. The only thing then that you have to decide is how much compute am I going to throw at this solution? So that is a really important thing to consider. We can also restrict access to Synapse by putting it behind a private endpoint. So from a network perspective, you can guarantee then that it's only accessible within your internal environment. Tagging, super important on resources in Azure if you want to see what's going on and who owns what. And it's as simple as that. So it'll validate everything that I've put in there, make sure that I'm not doing anything dodgy, and then it will allow me to create that. But as with all good cooking shows, here's one I created earlier. It takes a few minutes to spin up. But as part of the creation, what you will get, and if I go to my resource group, which is this one, what we get is our storage account, and this is by default, and we get our Synapse workspace. Now, I have created a dedicated pool in the meantime, but that is basically what you get. If we go into the properties, you'll see sorry, that's the wrong one. I need to go in here and select the properties. So you will see the details of what your SQL admin username is and what your SQL Active Directory admin is. By default, because I created it, it's going to assign that to me. Also in the SQL pools, you're going to see that we have our serverless pool is created by default, and we have our dedicated pool. But really where all the fun happens is in our Synapse Studio experience. So if we click on that link, that will take us to here, which is our Synapse Studio experience. When you log into your workspace initially, you're going to see this screen, and down the left, and it's very similar to the Azure Data Factory experience. So you have your home page, your data page, your develop page where all your scripts are, integrate. So this is where your Synapse pipelines are. So Azure Data Factory sort of stuff, your monitoring and your management. I'm not going to go into them in a lot of detail because what we want to do is, okay, you've installed Synapse. What are you going to do with it? And in here, there's a great area called Learn. And you can click on Learn and you can click on Use Samples Immediately, and it'll start giving you some sample data sets, some sample code that you can start playing with. You can browse the gallery. So here's some of the data sets that you can play around with, because that's always something I run into issues with. You know, give me some good data that I can play around with and start working with. We also have some SQL scripts in here that work with these data sets as well. So it'll show you the structure of the statements. So if I click on this one, query JSON files, I can just click on that. It's going to ask me where I want to deploy it. In this case, it looks like it's defaulting to the on-demand. And if we open that script, what we have is some sample data sets in these storage accounts. And you can just run those queries. It's just waiting to connect to. I made the fatal error of demos. I didn't warm up prior to doing this. Damn.
Oh no, Henry.
I know, I didn't do the warm up.
Henry.
Dear, oh dear. Anyway, while that's warming up, lucky I have something in the background to show you. I will go through just briefly what Synapse is. So let me click on here once it shows up. So we have our Synapse Analytics. And in there, we get our data lake storage. So As mentioned on the install, you can create your own data lake storage, or we can connect to another. And this is where, you know, we can integrate with other systems really well, taking advantage of the common data model. We're also working a lot now with the industry data models. Definitely something, write that down, make a note of it, and look that one up. Fascinating area. But what we have created is a platform that's secure. You can manage it, you can monitor it, that will allow you to integrate your data. We have multiple runtimes available, so you can run your Spark and your SQL in the same user experience. And we have that in an on-demand and a provisioned format as well. And I will be talking a bit about the on-demand a little bit more. But this shows you then that, you know, it's just a really accessible, easy to use platform that allows people to collaborate across multiple languages using multiple runtimes across a wide variety of data. So that could be semi-structured, structured, or unstructured data even. Just because it's not semi-structured or structured doesn't mean you can't use this tool to analyze that data. You may not be able to land it in a data warehouse, but there's many other ways to analyze data within your organization. So that is very brief overview of Synapse. But what I wanted to do was talk about the MPP engine and the SMP engine. And are there any people who are sort of wondering, you know, why do we need a different engine? Why is this required when it comes to querying data in a database? You know, because we've got SQL. Why do we need another type of SQL? Well, what I'll do is I'll just briefly go over SMP. So SMP is, you know, your traditional SQL Server where we have a shared environment. So pretty much we're sharing all the resources and all the users take advantage of that. With the MPP, we sort of have a shared nothing attitude on that. And I'm going to say shared nothing, but, and remind me to come back to the but when I forget to talk about it a bit later on. But really what we're talking about is distributing that workload across multiple compute and storage services. So you have a head node or a master node, or, you know, there's numerous names around that. And that handles the user connections coming in, and then it distributes that to multiple engines in the background, where it can scale that out across multiple compute capabilities to return the results faster. And the analogy that we use around this is, if you give someone a deck of cards and you say, give me, you know, all the aces in the deck of cards. So you have to go through 52 cards, and you go through them one by one and you find all the aces, and great, you get the result. But if you give that deck of cards to 4 people, then they only have to check 13 cards instead of 52 cards. So they can get the results a lot faster returned back to you. Imagine if you had 52 people and say, give me the 4 aces. Well, you're pretty much going to get an instantaneous result. And that's the main difference between SMP and MPP. So here's an example of a query coming in. So the user connects, the control node determines how best to distribute that query, and it sends that to all of these subnodes in there. So if you have a filter, if you have a join, if you have something that will allow the optimizer to determine, okay, I know that all the Smiths are here and the Joneses are here and stuff like that, and that's the information you're looking for, it will know how to distribute that data across these. I'm sure there's much better examples than that I could have come up with on the fly. But that's sort of what we're looking at with respect to this. So your distribution of data is very important when it comes to getting good performance. And we will talk a little bit about distribution.
Henry, just before you go
Yes.
on, question that's come in. Is
Yes.
MPP faster than SMP for querying small sets of data?
I would say, you see, it depends on what your definition of small is, but I would say, yes, it is not going to be as fast, potentially. You know, if you've got a table with 100 rows in it and you query that on SMP, well, then it just has to go to one storage repository to retrieve that information. And there's a very good chance it may already be in your buffer cache. If you have that on MPP, well, it's going to have to go to multiple compute nodes if you've distributed that data and return it. But this is where it comes down to the distribution of data as well. So yes, ideally you want to be working with large data sets. What I would say more accurately is you want to be returning large data sets. So if you're only querying for individual rows, well, then that's not really the job of a data warehouse. So it's the data warehouse workloads that it's ideally designed for, not your operational workloads.
Thank you very much.
So in step 4 here, we see that the compute node executes its particular portion of the query. So if you have the data distributed, alphabetically, the top node being, the first, if we have let's say there's 26 nodes here. So these are all the A's, the B's, the C's, the D's. It's just going back and pulling back what it requires from each of them, and taking that back in there. Then as we go along, the results are returned to the control node, and then it sends the results back to the user who executed the query. So that's pretty much how MPP works. There's probably a few more technical things that happen in the background, but that's why you would use this service, and that's how it can deliver the very quick responses across very large data sets. But when we're starting off with Synapse, I would say you don't even need to get into the actual MPP engine, because remember, it's something that's optional that you enable after you deploy Synapse. What you get when you start off is your on-demand pool. And that's something I'm going to talk about in a second. But, and if you remember, and nobody told me to talk about it, I said that MPP was a shared nothing. However, in Synapse, we do have the option of result set caching, which, similar to your buffer pool to some degree in SQL Server, if you have data that you know that users are going to be querying frequently, what we can do is cache that data within Synapse. And a classic example is some Power BI reports or something like that. So it actually doesn't have to go back and retrieve that information. It's actually stored in a cache to allow much quicker response on that. So that's a feature that Synapse has that's generally outside the MPP architecture. Now, why didn't anyone pull me up on that and remind me to answer that question? Shame on you guys.
Because I was waiting for the prompt of when you needed to, but it seems like you reminded yourself.
Yeah, I know. And my memory is terrible these days.
But you've done well.
I have. I'm impressed. And Olaf was slagging me off earlier on for starting work on databases in the 1970s. So I've also remembered that, Olaf, and I'm not going to let you away with that.
Oh my God, I'm going to hide now.
Yes. So that sort of covers off MPP very high level. So know it's there if you need it, but starting off in your journey, you don't need to use it straight away. And that's what I would say. Because if you're starting with Synapse, start off with the on-demand, because there's some great features in the on-demand that are not immediately obvious. So what I wanted to do was talk about, before I show you the on-demand, some things that you want to do with the on-demand before you start playing around with it. Option number one is to enable query acceleration. And I have a reference in here, which it's probably worthwhile looking that up. But essentially what query acceleration does is it allows you to push down some predicates to the storage and the compute in the storage to reduce the amount of data that's actually returned to, in this scenario here, which I find is really intriguing, a client application. So that application could be Synapse, it could be Power BI, it could be anything that's interacting with your Azure storage solution. But if you think about the way your data is stored, and let's say you have data stored by month, and it's all stored in one storage container, you can actually say, just give me the files where the month is March, and actually it'll just filter that out at the storage level rather than bringing the entire container over to your client application and applying the filtering then there. The advantage of that is, first of all, your queries are going to run faster. Secondly, it's going to cost you a hell of a lot less money because you're not using the expensive compute in your client application to return that data. You're using the very inexpensive compute in your storage service to return that information. So that's a really important point I wanted to get across, and I think I have a slide or a link on that. There's a link in the slide as well, which I can share at the end, but it'll show you what features are supported and what aren't. So there's like operators are supported, greater than, less than. There's quite a few in there, and it's definitely something worth taking advantage of. Where this fits in with the SQL On-Demand capabilities is, you know, as I mentioned, you could have Power BI querying that, but also you could have your Spark engine querying your storage, anything going through SQL Server Management Studio connecting to the On-Demand. And with the query acceleration enabled, so you're going to get much better response, but using the SQL On-Demand, you only pay for the amount of data that has been queried. It's, I think, $6.80 per terabyte that's actually returned to the service. So if you can reduce the amount of data that's been returned to the SQL On-Demand service by leveraging the query accelerator, that means you're actually going to reduce that cost even more. Now, for spinning up Synapse and using the SQL On-Demand, and you could be querying terabytes of data, you're going to have a very insignificant cost profile within the organization with respect to the activities that you're performing, especially if you compare that to the cost of the MPP engine. So what we want to do is allow people to do their exploration and discovery in the on-demand, where nobody really cares how much it's costing because you're never going to break the bank using that. And you can start to build your hypothesis or start your data engineering activities, or just, you know, mashing that up with curated data sets that may already be in your data lake, and see if you can generate additional insights out of that. But it's just going to allow you to produce more very, very quickly, very low risk to the organization, still very secure because it's all within Synapse and Data Lake, and just, you know, be a much better end user experience, because You know, you're not asking for these resources. You're not trying to justify the costs. It's all so small that people aren't going to worry too much about it. So I wanted to show you this. So if I go to my serverless pool, and we have a database in here. So you can create multiple databases within your serverless pool. So if you want to have your own database, you can in there. And what we're doing is we're just connecting to a storage account, and we're just going to return 10 rows. So it started that query, and basically this is it here. So it's returned some JSON from this storage account. Now you can read classic JSON as well. And then there's JSON L, and I forget what the L stands for, and I'm sure Mike will jump in on that. Line delimited or something like that. Is that what it is? Where they've already put the row terminator in there, so you actually don't have to define it. But what we can do, and I'm going to scroll down on this, we can actually put it into a structured format as well. So I think this is the query that will do it. I'm not sure, but we can apply filters to the query. So it's actually using the query accelerator now to ensure that only specific result sets are returned. So this isn't querying a table in a database. This is just querying directly off the blob storage from a CSV format. Well, it's saying it's CSV, it's actually a JSON document. There are numerous formats supported, so Parquet, CSV, JSON. I'm not sure if there's anything else that's been released lately, but really the common ones that we see at the moment are CSV and JSON. I'll come back to that one when just to see when it completes. There was one other thing I wanted to show you when connecting to Synapse. We can connect through good old Azure Data Studio, which is what we are probably used to at this stage. You can actually connect through Management Studio as well. But I wanted to point out two subtle differences here. So you have a connection string for your on-demand and also for your dedicated. It's important to understand that you're using the correct connection string within your Management Studio experience or your Azure Data Studio experience or in Power BI. So you can have Power BI using the on-demand connection. So if you're not worried about your data refreshes taking too long, you don't need that instantaneous response on your refreshes of data, whether it happens overnight. Maybe the data sets aren't massive. Maybe it's not a complex query. It's certainly a viable option to refresh your data within Power BI. So let's see if that has finished yet. It hasn't finished yet. Let me have a look at another one here. So here's just another query connecting to some New York taxi data. This is in the Parquet format, and Parquet is really good because it's highly compressed. So if you can get to work with Parquet data sets, I would definitely recommend it. But that's why I think the on-demand is sort of going to be your best friend, especially in the starting days in Synapse, because of its incredibly low cost point, the fact that it's so familiar when you're just running queries, and the fact that it can just operate across that data in your data lake. So you can actually join between these data sets. You can create views of these data sets in your on-demand or external tables and just check to see the differences. There's a few differences between external views and external tables. So have a look at those capabilities in there. But you can actually get a lot of insights out of your data by using this. and as I said, the cost is minimal. On to the distribution of data. I think some people spend a lot of time discussing the distribution, but really, step one, use your serverless to do some analysis. Now, when you know you want to, okay, I need the MPP engine, I need to do some stuff in there. Then you have to think about, okay, how am I going to distribute my data in there? And there's three options. You have replicate, you have hash, and you have round robin. And when we think about the options here, we have our replicated table. So rule number one is for dimension tables, you would replicate them. And that means that there's a copy of that dimension table on every storage service that is in your MPP engine. So in this scenario where there's sort of 4 compute nodes being displayed, that dimension table will be copied across every storage service that's connected to that compute node. The reason you would do that is because it's not a large table. So it's designed for tables that are not particularly large. And I think there is guidance on that. And I can't remember, and correct me if I'm wrong, Tanya, I think they sort of say around 4 gigabytes in the table. I'm not sure, but something around that. It's certainly documented on the site.
I don't recall anything around size in that regard. It was more about number of records.
Yeah.
It was 2 gigabytes.
2 gigabytes.
Just clarify that. Yeah.
Yeah. Now they are changing that, I believe. They are going to make it bigger, but remember, that's just guidance. It's just finger in the air. So my recommendation would be just test it out and see what works. The advantage of having it replicated across multiple storage services is if you have a table then that's distributed across all of them, it means then you don't have to the copy of your dimension, which you will be joining to, as you always will be when you're querying a fact table, well, not always, but in 99% of cases, it means that that join data that you require is on every storage node that you have your fact table distributed across. So you're avoiding what's called shuffling within your MPP engine, because what you want to avoid is shuffling, and shuffling is where data is moving between compute nodes within your MPP engine. You want everything that your compute node needs to be there within the storage, so your compute node can service that particular part of the query. As I said, there's a lot to this. The other option is distributed. Now there's 2 options on distributed, and if we see this sales fact table, it's distributed across all of the storage. So it goes from this storage pool all the way across, and this is where that data is, there's no single location where all that data resides. It's striped across all of those. If you think about it from the SMP world, it'd be like partitioning your table to some degree. Now, with your distribution, you have hash or round robin. And I get a lot of people asking me, oh, should I use hash? Oh, they say hash performs better. I would always say just start off with round robin, unless you really know the types of queries and you really understand the structure of your data warehouse. Just go with round robin, because what happens to a lot of people on hash is they get an uneven of distribution of data. Round robin will ensure that your data remains evenly distributed across your storage. And that's more important than having queries optimized for the hash distribution. So starting off, small tables, replicated, especially if they're dimensions and your fact table is joined to them all the time. Large tables, fact tables, just go with round robin. And then as you understand the profiles of your queries and the performance of your queries and how your data is distributed, then maybe start considering the hash option. But don't spend a lot of time on it. Just start off with round robin, go for it, see how it works. So that is my very quick 101 on distribution. So the last thing I want to cover off is clustered column store indexing. So this is the, this is the default for your tables when you create them in Synapse. It will apply a clustered column store index to it. And this is a highly compressed way to store your data. And this helps with the performance of your MPP engine, because the more compressed the data is, then the less disk reads it has to perform, so it can return the data very quickly. But there's something that you need to take into consideration for clustered column store, and I believe it's something that people should understand. And the reason I'm bringing this up is because I've seen people apply this to operational databases, and it's not ideal for operational databases. So clustered column store was more designed for your data warehouse workload. So ingesting of data and returning large amounts of data. There's a specific nuance to clustered column stores which you should be aware of. And when you're loading the data, so these are the rows that we're loading in. So we've got a large amount of data that we're loading in, and it puts them into row groups. And when those row groups are full, which means they have, what is it, 100, over 100,000 rows in a row group, it's able then to apply the compression to that data, but only when the row group is full. Anything else goes into what's called a delta store. And the performance, if you're querying off the delta store, can be less than ideal. Now, the thing is, if you've got 50 billion rows in your table, your delta store is going to be tiny and it's not going to matter. If you apply clustered column store to an operational database and you're always querying the active data, which may be the most recent data that was inserted, you could be always querying the delta store. So be aware that your performance could degrade quite significantly. So great compression doesn't always mean great performance. Now, with Synapse, you are not forced to use clustered column store, and there's definitely some indexing tips and tricks that you can take into account. But you can use traditional clustered indexes. You can have heap tables in there as well. So all of these strategies are still valid when it comes to Synapse. So, you know, if you're loading in a large amount of data, you could just land that data in a heap just for speed and then look at post-processing on that. In certain scenarios, if you've got a very large table in Synapse where you want to delete a lot of rows and insert a lot of rows, sometimes it's better just to make a duplicate of that table with the new rows and then drop the old table. So don't assume that clustered column store is the only way to go, and it's always the best way to go. It's the same as any other database. You know, you always want to be tweaking things and testing performance and then comparing results as you change the environment. So have a look at the indexing. It's definitely something worth looking at. And, you know, always keep an eye on your indexing and your query performance. It's the same as any other database engine, and it's the same as any other relational engine. You're dealing with a lot of data. You're going to have to optimize it. You're going to have to keep an eye on it. So with the MPP, your distribution and your indexing, some things to think about. look at your on-demand. If I go back to the previous slides where, let me just get out of that. So the final quick thing, and this is something I see people getting tripped up on as well when they deploy Synapse, is the workload classification and the workload importance. And what I've seen is 1,000,001 times, including myself, let's be honest, is I've spun up a Synapse and I'm pulling data in, and it's a large data set using some of the sample data sets there. I'm running a query across them, and it's not performing as fast as I would like. So what I do is I kill the query and slide it up to DW 1000. I go, oh, that's going to sort it out. That's going to get it going. And I run the query, and it almost seems to be running slower rather than faster. And what you need to remember is when you create Synapse, you're an admin. And when you're an admin, by default, you are added to a workload classification, which is the smallest workload classification. So therefore, your access to the resources within Synapse is severely curtailed. And if you're running your data loads under your admin account, which I do all the time, or you're running your queries under the admin account, well, then the performance is not going to be great. And here is a table where it sort of highlights the resources that you're entitled to. So by default, as an admin, you'll only get 25% of the resources when you're running at DW 1000. You crank it up to 1000, you're only going to get 3% of the resources. So it is a scale where your workloads classification is really important to consider. So if you are loading a lot of data, you want to make sure that the account that's loading the data has access to a large set of the resources. So putting it in the correct work group and the classification is super important. So that is workload classification. I just say it's how much you get. And then there's the workload importance. So where are you in the queue? So let's say you have a lot of queries coming into Synapse, and there are certain levels of concurrency based on the service level that you're working at. And a lot of people get pretty freaked out about concurrency. Oh, I only get this, 10 concurrent threads or 20 or 30. You have to remember that the queries tend to run pretty fast. So I hear a lot of people worrying about concurrency, but when they're actually running the service, I never hear them complaining about it. So it's another one of these things, is just deploy it, see what happens. If you're running into concurrency issues, let's talk about it. If we can make your queries run faster, we'll probably get rid of your concurrency issues, those sorts of things. But with workload importance, if you have concurrency on the service and you're put into a queue, if you prioritize specific workloads, it just means that as soon as the next lot becomes available, the high priority activities will jump the queue and then they'll be executed next. So in here, we have some of the code that allows you to add users and roles to particular work groups. It does mention the exceptions on some of these activities. So understand what the exceptions are, and then you can also add the classification. So if anyone's familiar with Resource Governor in SQL Server, it's Resource Governor for Synapse. Pretty much that's what it is. But it's a very important one to remember, because when you run your Synapse up first, remember you're in that default small resource classification where you have very limited access to resources. So if you want to play around with a large amount of data, create a new login add it to the right classification, and make sure that all of your activities are running under that.